Okay, the community center wants to build a playground area and enclose it with a wooden split rail fence. The cost of fencing is $20 a foot, and then we have to paint it for $12 per finished foot. Looks like that's gonna cost us $32 per foot. Okay, so let's just write that down here. Cost, whoops, get my pencil here. Cost is $32 per foot. All right, just to kind of get our information down here. We've got a rectangle that we've got going on here. You can't spend more than $2,000, and it says the playground cannot be any longer than 30 feet, and it can't be, or it has to be at least 15 feet wide. Okay, so I mean this choice is arbitrary, but I'm going to say that my length is X and my width is Y. So I've got some requirements for that. It says it can't be any longer than 30 feet. So basically, X has to be somewhere between 0 and 30. All right? So 0 is, or X is greater than 0 is less than or equal to 30. All right? Y has to be at least 15 feet wide. So we have Y is greater than or equal to 15. All right, so we need to write a cost function yet. Looks like, well, think about what it's going to cost us. Okay, we've got, how many of these sides do we have? We've got 2 of these sides, and we've got 2 of these sides. So, look, people, it's going to be 2x plus 2y. That's the perimeter, okay? So this represents the total perimeter, and how much is it going to be for every foot? $32, okay? So we know that that is a true statement, and it has to be less than $2,000. So less than or equal to $2,000. All right, so let's just use the distributive property on this. This gives us 64x plus 64y is less than or equal to $2,000. All right, the deal is, though, this is the parameter for x, and this is the parameters for y. So I'm thinking let's go ahead and plot this on the on Desmos, see if we can't figure out what the vertices are, and then we can figure out how to maximize it, maximize the area. Okay, so here goes. Our first equation is going to be 0 is less than or equal to x is less than or equal to 30, I believe. Okay, so there's that. And then the next equation, let's just hit this, there we go. The next equation is going to be y has to be greater than 15. Y is greater than or equal to 15. All right, so there's, we've working on our constraints here. Now, I think we had, oh goodness, I didn't write this down. So I think it was, let me go back here. 64x plus 64y is less than or equal to 2,000. Okay, so 64x plus 64y is less than or equal to $2,000. There we go. Whew, wow. Okay, it's off the charts here. So I think I'm going to have to make this a little smaller so that you can actually see what's going on. All right, yeah, you can see there what's going on. You see where those all overlap? So let's see what our vertices are here. There's that, that, and that. Whoops. Click on this here. Yeah. Okay, so it looks like we have 3 vertices. So write these numbers down. 0, 31.25, 0, 15, and 16.25 times 15. Well, I'm suspecting that you already know which one it's going to be, because if you choose either of the ones that have a 0 in it, you won't even have, you'll have nothing. You'll have no playground, because if one of the dimensions is 0, you're just kind of stuck. So hopefully you can see pretty quickly that what we're interested in is the number 16.25 as our x value and 15 as our y value. So now let's look at the question here. Okay, so what is the maximum area? Well, here is our maximum area. Okay, so 16.25 long, right? And then 15 is the width. Okay, so how much will this cost? Okay, so just plug this 16 into this, and plug the 15 into here and see what it spits out at you. 16.25 times x, whoops, this right here, times 64, and then we've got 15 times 64, and figure out what that equals, and that number will be your cost. And I'm going to let you do the math on that. I hope this was successful for you.